So, hello, I am recording this at 3:12 IST, 3:12 a.m. IST, and the deadline is around 5 a.m. IST. And I don't know if you can see, but I'm going to sleep very soon. So, let's just look into our project really quickly. So, yeah, not this. Yes. So, this is the website I had to create because you guys didn't allow me to submit it without a website. But trust me, my tool doesn't need a website. and I and this is a website. I'll be honest, I don't know how to do front end because I don't like it. But and this is all made by Amazon Q, by the way. This is really very interesting. I click these screenshots, by the way, along the lines of while creating project thing. And this is how you can just go ahead and get started. Yeah, allow it to open the link, and it opens this for you. Now we can just clear the history because I want to demonstrate how this works. Let's ask it, hey, what can you do? So currently, how this works is that our Telegram bot is connected to a API gateway, and it sends the tasks to ECS, and then ECS container basically spins up in an instant and handles your request. So for each user, a new ECS instance spins up. I'll just show you the architecture diagram while we wait for it to reply. It is taking a bit of a time because currently every time a user sends a message, it cold starts an ECS instance, and I'll show you how it works in a second. So here, so you are the user here, and then you send a API invoke through API gateway. A Telegram handler is there, which a Telegram handler Lambda function is there, which handles your request and sends it to a Scout agent. So what a Scout engine does is that it handles the general queries as well as does all the heavy lifting. It searches for hackathons, it makes its own tools, it creates all the things it needs, it scrapes the website and then finds its own API, internal APIs, and it is all done through HTTP internal tool of strands. Then as you can see, it uses the knowledge base of Bedrock. I have stored around 20 to 30 websites as a trusted source, and it also uses Bedrock for its model invocations. This is all done in an ECS container, as I told you. It is Scout Agent Service and a container. Telegram is just a handler. It just sends the key here to here. It just sends the message. Then it stores user preferences in a open source serverless collection. It stores it in vector and that not and then the original knowledge base I talked about, it is stored in an S3 bucket. Then we have our chat history. This is basically for idempotency check in our Telegram handler. Then we have the discovered hackathons. Let's say it discovers 12 to 13 hackathons. It then just stores them in this. And if you just ask it to tell you about some hackathons, it can just retrieve it from there if you don't specify any preferences. Then we have scraper functions. I told you that this ECS service, that our Scout agent service can generate code. It shows it here in this scraper functions table, and then it runs it in its own environment. And because the clusters are ephemeral, the containers are ephemeral, it doesn't matter if the code is malicious, it just gets turned off anyway. And then we have a wait a minute. And then we have a user interest. So this is basically, let's say you want to track a hackathon. So you just tell the agent that, hey, I want to track this hackathon. Just store it from there. It just stores it in the user interest table, and then what it does is it sends you reminders about it, and those reminders are sent through this nudge agent lambda. What this does is it scans this whole database, and then it queries notification history and process messages, sleeper functions, hackathons, and then it sends you a reminder of some hackathons that may be ending soon or the new hackathons it discovers. What it does is basically every week it sends you a new hackathon. hey, I found this new cool hackathon. You might like it. These are this is according to your preferences, and it will send it to you. So this is the whole architecture. There is also a queue which helps this guy over here to keep track of his messages and send the messages. And while we were talking about this, yeah, it worked. So see what you can do. Task completion, hackathon discovery, yada yada yada. And I had basically asked it to create dev post scraper, and it probably does have it still. Okay, wait one minute, please. I'll just ask it to hey, get some AINM from dev post. Let's say. I'm asking it to check internal APIs currently because I know it can take some time. So I'm just giving it a hint. Okay, you can do that. Other than that, we already have a, how should I say it, classifier which asks it to, go and look for the internal APIs. I can just show it to you the system prompt. I can just show you the system prompt right now. Here it is. So this is our big ass system prompt. Here, if it found that there are internal APIs, then it just goes to that API and executes it. It is all possible because of Strand's HTTP request tool. It is an inbuilt tool. We have also given it bypass tool consent is true because so that it can run a program. As I said, it makes its own tools and then runs it. So there is a global rule that it should report progress to keep the user in loop. It was taking a lot of time, so then I just like, and now it takes the same amount of time, but it actually keeps you in loop. Then we first do a freshness check. So let's say I ask it to bring me 2026 hackathons. So it will just get stuck in a loop for a really long time, for around 20 minutes. It keeps searching every website there is for hackathons that may be happening in 2026. So this is a freshness check. Then we classify our user's intent. Maybe he wants to update his preferences, or maybe he wants to do a general query. Maybe there is specific URL that he wants to check. Then we execute a current path. We have three paths: preference update, general query, and checking in specific URL. And this is a really, really long prompt. And this prompt was written, this prompt was, I'm sorry, Amazon Q helped me write this prompt. I gave it a basic prompt and asked it to refine it for Claude 4.0 Sonnet. And through some iterations, we reached it. I am currently using Anthropic Claude 3 Haiku to generate a summary. Yeah, Strands uses a summarization model, summarizing conversation manager. Strands has many conversation managers, and this is what I chose because it works the best for my use case. I just ask Claude Haiku to generate a summary of if the conversation gets too long. And yeah, this is the whole code. I use Claude 4.0 Sonnet for the main agentic work. It should be here. Yesterday. Yeah, here it is. This was the code, and other than this, yeah, it is. It checked its own internal tools and it found them. Fetching AI/ML hackathons from Bitcoin using other existing tools. Task complete. It found these hackathons. Yeah, Agentic AI Global Hackathon. Only 1 day left. This is what I'm preparing for. Nice. Yeah, accelerate. Blah blah blah. Thank you so much. Now let's look at our tables that I created. I know it is supposed to be 3 minutes, but let's see. It is. scraper function. Let's just explore the icons here. Here you see dev post. It was able to find an API endpoint. That is why it just stored all the APIs that were there, and then I didn't have to use any scraper function or anything. For MLH, we did have a scraper. MLH के लिए we made this. It was on this URL, though it should be 2026. Then it made a URL like this. The scraper function like this. It made it for a lot of websites. Here it is for hackathon. It made a scraper function. And yeah, these are the websites here that all hackathons they post and stuff. We can also put any website we want. Let's just search for a website. Hackathon on website. Mm, mm, mm. Let's say SIH. SIH is a Indian hackathon. It will be, yeah, let's go to that first. Here, finally, hackathon um, request. We have also generated this function. I don't know how long it's been since I started recording. It's been 11 minutes. Shit. But yeah, this is the demonstration I wanted to do.